There's a fascinating idea making the rounds. It begins with a thought experiment. Imagine you place a single perfect apple inside a perfectly isolated cube. You seal it off from the rest of the universe. No energy gets in, and no energy gets out. The claim is that if you wait a long time, an almost unimaginable stretch of time, the atoms that make up that apple will rearrange themselves. They will explore every possible configuration that the laws of physics allow. Over eons, the apple might dissolve into a cloud of gas. It might flicker into a strange plasma. And if you wait even longer, those same atoms might randomly arrange themselves into a baseball. This idea doesn't stop with just an apple. It suggests that this principle applies to everything, everywhere. The universe itself, according to this story, is on a grand journey to explore every possible state of existence. After it has tried everything, after it has been everything, it resets and starts the cycle all over again. This grand cosmic narrative is often linked to unnamed figures. Some accounts claim to describe this theory and even portray arches, gateways to other universes where different possibilities play out. It's a powerful and captivating story of infinite potential. The appeal of this story is easy to understand. It taps into our deep-seated wonder about the universe and our place in it. The image of an ordinary object transforming into something completely different through the sheer passage of time feels like a kind of magic, but still rooted in science. Words like quantum states and alternate worlds are used, giving the whole concept a veneer of scientific authority. It suggests that the cosmos is far stranger and more full of potential than our everyday experience lets on. It makes us feel like we are on the verge of a profound discovery. But in science, a good story is not enough. A compelling idea is just the starting point. The real work begins when we ask a simple but powerful question. Is it true? To answer that, we have to do more than just imagine. We have to look for evidence. We have to check the facts. We have to see if the claims stand up to the rigorous scrutiny that science demands. We must separate the story from the science and see what, if anything, holds up when we turn on the lights and examine it closely. The journey from a captivating idea to an established fact is a long one, paved with data, experiments, and peer review. To be fair, the story of the transforming apple borrows concepts from legitimate mind-bending areas of physics. One of these is a field called statistical mechanics. This branch deals with the collective behavior of huge numbers of particles, the atoms in an apple, the air in a room. These particles are in constant random motion. Over immense timescales they can, in theory, arrange into highly improbable configurations. The idea that particles could, by pure chance, briefly form a different object is the Poincare recurrence theorem applied to a specific system. The story also touches quantum mechanics, the physics of the very small. One debated interpretation is the many worlds interpretation. Every time a quantum event has multiple outcomes, the universe splits into different branches. Each outcome happens in its own separate universe. In one universe, a particle went left. In another, it went right. This gives a theoretical basis for parallel Earths with different histories. The Arch's technology in the story reads like a direct application of that speculation. The story also mentions quantum entanglement. It's a real proven phenomenon. Einstein called it spooky action at a distance. When two particles are entangled, their fates are linked, however far apart. Measure one, and you instantly know the corresponding property of the other. The idea of a ship using entanglement for faster-than-light travel borrows from that instantaneous connection, suggesting a way to bypass the universe's ultimate speed limit, the speed of light. These are real concepts physicists study and debate. The problem isn't that the ideas are complete nonsense. The problem is how they're stitched together and exaggerated. Real scientific theories come with massive caveats, mathematical limits, a clear distinction between what's proven and what's hypothetical. These narratives take the most speculative, dramatic parts, strip away the limitations in the math, and present them as established fact. It turns a what-if thought experiment into a "this is how it is" declaration, and that is a very different thing. In science, discoveries are often tied to public papers and open debate. Think Newton, Einstein, Curie, open records, citations, conferences. By contrast, some work proceeds in the shadows by necessity. Sources describe Dr. Michael E. Blackwell as operating under extreme secrecy. Projects are compartmentalized. Collaborators sign strict NDAs. Funding is routed through intermediaries, and oversight limits what can be disclosed, even to teams on the inside. So if Blackwell pursued sensitive principles or prototypes, we wouldn't expect a typical publication trail. We'd expect silos, need-to-know access, and delayed disclosure instead. Peer review footprints would be minimal, by design. University ties, if any, would be contractual and off the record. Patents could be filed through shell entities or defense partners, masking inventors. Mentions in mainstream outlets might surface as background notes or unnamed sources. So, we look differently. We comb procurement filings and technical vendor records, institutional archives with redacted memos, patent clusters and opaque assignees, conference agendas for closed sessions or unexplained demos. We search for Michael E. Blackwell alongside quantum programs and advanced systems, terms like arches, gateways, or classified initiatives. Hints and leaks become deniable breadcrumbs, consistent technical details across independent reports. Our open-source sweep returns very little tied to Blackwell, consistent with tight secrecy. Peer-reviewed papers are scarce, likely because any real work wouldn't move through academic pipelines. Faculty rosters and lab pages omit names connected to restricted programs, so his wouldn't appear there either. Patent trails, where they exist, route through holding companies and contractors, not named individuals. What does surface are brief mainstream snippets and database crumbs, trade show whispers, and forum chatter. Occasional posts recount Arch's demos, secondhand, never on record. Across outlets, recurring mentions cite Arches, exotic transport studies, and entanglement-based systems, intriguing but without official confirmation or named sources. That lack of verifiable attribution is a caution flag, not a final verdict. In modern science and tech, breakthroughs that intersect defense or high sensitivity often leave sparse public footprints by design. Programs built for deniability can run for years with minimal open literature, so absence in journals here is context, not dispositive on its own. It suggests the claims, if real, may be pursued outside normal academic channels, or they remain unsubstantiated. Both possibilities must stay in view. Institutional opacity, code names, umbrella contracts, and plausible experts without bios is a known pattern in restricted projects. When separating fact from story, source credibility and traceable documentation remain paramount. Until named sources and primary records emerge, the careful path is to correlate recurring technical details across independent reports while acknowledging that key evidence may be compartmentalized. Imagine a simple apple. Now, seal it in a perfectly isolated box. Over eons, the apple's atoms could rearrange, dissolve into gas, or even become something entirely new, like a baseball or a block of iron. This mind-bending idea, called recurrence, shows how even a humble apple hints at the infinite possibilities of our universe. Meet Dr. Michael E. Blackwell, a visionary who stands on the shoulders of giants like Einstein and Bohr, but dares to look further. With a background in classical and quantum physics, he blends rigorous science with bold imagination. Driven by curiosity, Dr. Blackwell connects established concepts in new ways, proposing the universe as a closed system, subject to recurrence. His life's work, to build a machine that could prove his theory, a true modern-day pioneer. From a single apple in a box, Dr. Blackwell leaps to the universe itself, a closed system cycling through every possible state. Eventually, the universe must repeat, creating endless cycles and infinite worlds. Imagine countless versions of Earth, and even you, living out every possibility. The grand idea, born from a simple apple, sets the stage for an unprecedented adventure into reality. For Dr. Michael E. Blackwell, proving his theory is not enough. A life spent in theoretical physics has instilled in him a powerful desire to turn equations into reality, to transform abstract ideas into tangible exploration. His ultimate quest is not just to know that other Earths exist, but to see them. He has embarked on the most ambitious engineering project ever conceived, the construction of a vessel and a system that can traverse the void between universes. This is the culmination of his life's work. A project that combines his original theories with cutting-edge, and often secret, scientific insights. He aims to build a bridge between our world and the infinite others. The centerpiece of his invention is a structure he calls the Arch. These are not simple doorways but are sophisticated gateways designed to manipulate the very fabric of space-time. Housed within a specially designed ship, which also serves as his home and laboratory, the arches are powered by principles that stretch the limits of known physics. Dr. Blackwell's designs are based on his unique understanding of quantum mechanics, particularly the strange phenomenon known as quantum entanglement. Often described by Einstein as spooky action at a distance, entanglement links two particles in such a way that they remain connected, no matter how far apart they are. Dr. Blackwell theorizes that he can harness a scaled-up version of this principle. By creating a massive, stable entanglement field, his ship can effectively lock on to a parallel universe that shares a similar quantum signature. This connection, he believes, would allow for the transfer of matter and information instantaneously, bypassing the cosmic speed limit imposed by the speed of light. Passing through an activated arch would not be like traveling through space, but rather like stepping from one page of a book to another. It would be a form of transportation so advanced it redefines the very meaning of travel. This endeavor is fraught with immense challenges and dangers. The energy requirements are colossal, and the physics involved are so complex that a single miscalculation could have catastrophic consequences. Yet, Dr. Blackwell is undeterred. He is driven by the promise of what lies on the other side. By visiting these alternate Earths, he hopes to gain an unparalleled understanding of reality itself. He could witness different outcomes of history, study life that evolved under slightly different conditions, and perhaps even discover new laws of physics. His quest is the ultimate scientific mission to explore not just new stars, but new realities. To grasp Dr. Blackwell's vision, imagine a closed system. Nothing gets in or out. Our universe, he suggests, is the ultimate closed system. All matter, energy, and light are contained within, obeying unbreakable physical laws. This sets the stage for his paradox, placing the cosmos inside an unimaginably vast box and asking what happens over time. The second law of thermodynamics gives us the arrow of time. Disorder or entropy always increases. That's why coffee cools, eggs scramble, and the universe drifts toward chaos. Yet Dr. Blackwell suggests a repeating universe. The second law isn't absolute, it's statistical. While it's almost impossible for order to return with infinite time, even the strangest things might happen. Entropy measures disorder, the number of ways a system's parts can be arranged. A new deck of cards is low entropy, only one perfect order. Shuffle them, and you get high entropy, trillions of possible arrangements. Although nature tends toward disorder, in a closed system, any state, even one of perfect order, will eventually return. This is the cosmic cycle of entropy. To truly understand our universe, we must enter the strange world of quantum mechanics, where particles exist in clouds of probability and can be in many places at once. Here, uncertainty is fundamental, and the universe plays a game of chance. Energy comes in discrete packets, quanta. So the universe has a finite number of possible states. This means, eventually, every possible configuration, including ours, will repeat. The Poincaré recurrence theorem, created by Henri Poincaré, says any closed system with finite states will eventually return to a state close to its beginning. It's a mathematical certainty, an ultimate comeback written into the universe. Even a shuffled deck of cards will, given enough time, return to its original order. The same applies to the universe. After unimaginable time, it must return to a state like the Big Bang, beginning a new cosmic cycle. The quantum Zeno effect, often called the watched pot never boils effect, shows that by constantly observing a quantum system, you can freeze it in its current state. In complex systems, like an apple, constant internal interactions act as measurements, reinforcing stability and slowing decay. Even the universe lingers in stable states, thanks to this effect, before making its next quantum leap. Quantum tunneling is a phenomenon where particles can pass through barriers they seemingly shouldn't, thanks to their wave-like nature. In classical physics, you can't walk through a wall, but in the quantum world, particles sometimes do just that. This effect is essential for processes like the sun's fusion, where protons fuse by tunneling through energy barriers. Even the most stable objects, like Dr. Blackwell's apple, have a tiny chance to spontaneously change, thanks to tunneling. Over unimaginable timescales, these rare events become inevitable, allowing matter to transform in ways classical physics forbids. Quantum tunneling is the universe's wild card, ensuring that no state is truly permanent and making cosmic rebirth possible. Dr. Blackwell's theory builds on a few key ideas. The universe is a finite, closed system. Entropy tends to increase. Quantum mechanics makes reality probabilistic, and the number of possible states is finite. The second law of thermodynamics drives the universe toward disorder. but quantum mechanics allows for rare, improbable transitions. The Poincaré recurrence theorem mathematically guarantees that, given enough time, the universe must revisit previous states. Quantum tunneling ensures even the most unlikely transitions can eventually happen. Together, these principles suggest the universe is not a one-way journey but a cycle, endlessly exploring every possible configuration. Infinite apples, infinite Earths, all destined to recur. Dr. Blackwell's leap is to treat the entire universe as a single, isolated system, just like the apple in a box. All matter and energy are contained within this cosmic box, with no outside influence. The laws of physics, conservation of energy, thermodynamics, quantum mechanics apply universally, no matter the scale. The universe's complexity doesn't change the rules, it just increases the number of possible states. Across the expanse of vast timescales, the fundamental principles that determine the fate of a simple apple similarly govern the grand destiny of the cosmos itself. We are not in an infinite void, but a finite, intricate machine, bound by the same laws. The apple was just the beginning. The universe is the ultimate system. The universe is a giant state machine, with a finite, though unimaginably large number of possible configurations. Most of these states are high entropy, cold and disordered. Our current structured universe is a rare exception. The laws of physics drive the universe toward disorder, but quantum mechanics and tunneling allow for rare returns to order. Over time, the universe explores every possible state, spending eons in heat death but never stuck forever. Eventually, by sheer probability, it will revisit low-entropy, structured states, like our own. Every possible universe is on the list, waiting its turn. Dr. Blackwell's theory leads to a staggering conclusion. The universe is destined to repeat itself. With finite states and infinite time, every configuration, including our own, must recur. The Poincaré recurrence theorem guarantees that, after an unfathomable span, the universe will return to a state identical to the Big Bang. Our entire cosmic history will play out again, exactly as before. Every life, every event, every decision, repeated endlessly in a cosmic cycle. Existence is not a one-time story, but an infinite loop written into the laws of physics. The universe is both eternal and ever familiar. The timescale for cosmic recurrence, the Poincaré recurrence time, is so vast it dwarfs the age of the universe. The number of possible quantum states is a tower of exponents, making the recurrence time functionally infinite for any practical purpose. For all observable history, entropy increases, and the second law holds true. The universe spends nearly all its existence in high-entropy heat death, with rare fleeting returns to order. Recurrence is mathematically certain, but separated by an ocean of time beyond human comprehension. This is the slow, patient rhythm of the cosmos, an endless cycle, measured in eons beyond imagination. The universe isn't just repeating itself, it's exploring every possible variation. Between exact copies of our world, there are near-infinite alternate realities, each just a quantum event apart. Every possible arrangement of cosmic particles becomes real, creating parallel worlds with subtle and profound differences, each a unique chapter in the universe's endless story. It's important to distinguish Dr. Blackwell's recurrence multiverse from another popular concept in physics, the quantum multiverse, often associated with the many-worlds interpretation. The many-worlds interpretation, or MWI, of quantum mechanics suggests that every time a quantum measurement or choice is made, the universe splits into multiple branches. In one branch, the particle is spin-up; in another, it's spin-down. This creates a constantly branching tree of parallel universes that exist simultaneously, all of them equally real. In this view, there is a parallel universe created every instant for every possible outcome of every quantum event. Dr. Blackwell's model is fundamentally different. It does not propose that the universe is constantly splitting. Instead, it posits a single universe that evolves sequentially through time. the parallel worlds are not coexisting branches, they are different configurations that our one and only universe adopts at different, incredibly distant points in time. It is a multiverse spread out across a single timeline, not one spread out across an infinite number of parallel timelines. Think of it as a single movie screen that shows every possible movie one after another, rather than an infinite number of screens each showing a different movie at the same time. The recurrence multiverse is born from the combination of statistical mechanics and a finite state space, as described by the Poincaré recurrence theorem. The quantum multiverse, or MWI, is born from one particular interpretation of the mathematics of quantum wave functions. While both lead to the idea of countless alternate realities where different possibilities are played out, their underlying mechanisms and structures are vastly different. Dr. Blackwell's theory has the advantage of being built upon a more classical thermodynamic foundation, which some physicists find more grounded and less speculative than the constant splitting of reality. This distinction is crucial for Dr. Blackwell's ultimate quest. In the many worlds interpretation, the parallel universes are thought to be completely causally disconnected. There is no way to travel between the branches. However, in the recurrence multiverse model, the different worlds are just different states of the same single system. This opens up a tantalizing theoretical possibility. If one could find a way to manipulate the quantum state of a region of spacetime, it might be possible to jump from the current state to a different one on the list, effectively traveling not through space, but from one version of reality to another. This is the principle his arches are designed to exploit. The implications of a recurrence multiverse are truly staggering when you focus on our own planet. Within the near-infinite set of possible universal states, there must be a vast subset of states that contain a planet virtually identical to Earth. These are worlds with the same mass, the same atmosphere, and the same distance from a sun-like star. On these infinite Earths, the great experiment of life would have played out again and again, but with different outcomes. Every roll of the evolutionary dice could have landed differently, leading to worlds both subtly and dramatically different from our own. Consider the history of our world. It is a chain of countless contingent events. What if the asteroid that wiped out the dinosaurs had missed? The recurrence multiverse suggests there is a universe state where that happened. In that timeline, an Earth dominated by intelligent reptiles might have evolved. What if a crucial battle in human history had been won by the other side? There exists a universe state where you could visit a world shaped by that alternate history. What if a brilliant scientist had made a discovery centuries earlier? A world with hyper-advanced technology could be the result. The possibilities are literally endless. These aren't just philosophical thought experiments. According to Dr. Blackwell, these are physically real places, snapshots of the cosmos, at different points in its eternal cycle. Some of these Earths would be so similar to ours that the differences would be almost unnoticeable. Perhaps the color of a particular species of flower is different, or a mountain range is shaped slightly differently. Others would be alien and strange, with different dominant species, different continents, and different laws of society. There would even be worlds where humanity exists, but our art, culture, and science took a completely different path. This tapestry of infinite histories provides the ultimate laboratory for understanding ourselves and our place in the cosmos. By studying these alternate Earths, we could see which aspects of our world are necessary outcomes of physics and biology, and which are merely the result of chance. We could learn about possibilities for social organization, technology, and life itself that we have never dreamed of. The existence of these infinite Earths transforms the universe from a single, lonely story into an endless library of all possible stories, each one bound in its own volume, waiting to be read. Dr. Blackwell doesn't just want to read them, he wants to build the key to open them. Scaling up the apple-in-a-box paradox to the universe forces us to confront deep questions in science and philosophy. The recurrence multiverse offers a bold cosmological model, an endless series of cycles, not a single beginning. Time zero may be just a local phenomenon in a much larger, cyclical structure. Philosophically, if history repeats forever, what does that mean for free will and the meaning of our choices? Dr. Blackwell sees this not as a trap, but as an infinite frontier for knowledge and exploration. Dr. Michael E. Blackwell believed knowledge was incomplete without application. For him, the recurrence multiverse was a blueprint, a map to new realities. He envisioned a machine to bridge universes, the arches. Like arches throughout history, his invention would be a gateway, connecting not just places, but entire worlds. At the heart of the arches lies quantum entanglement, what Einstein called spooky action at a distance. This phenomenon links particles across any distance instantly. Dr. Blackwell theorized that by amplifying entanglement, the arch could resonate with parallel universes, creating a stable, traversable wormhole, an elegant shortcut through the multiverse. The arch demanded more than a simple vessel. It needed a revolutionary ship, a self-contained world for Dr. Blackwell's journey. This ship is his home, lab, and sanctuary, built to support the arch and survive the unknown. Its core houses the arches, surrounded by advanced tech, quantum computers, and exotic materials, a perfect union of science and engineering, worthy of the first explorer of the multiverse. To open a gateway between worlds, Dr. Blackwell needed more power than any reactor could provide, energy closer to a star than a power plant. He turned to the quantum vacuum, tapping zero-point energy, an endless sea of virtual particles in empty space. His vacuum energy siphon draws this power, fueling the arch and making the impossible possible. Traveling between universes is not like traveling between cities. You can't simply point in a direction and go. The recurrence multiverse is not a spatial landscape, but a state space, a conceptual map of every possible configuration of reality. To navigate this map, Dr. Blackwell needed a new kind of compass and a new kind of cartography. He developed a system based on what he calls quantum signatures. He theorizes that every complete universal state has a unique, complex quantum signature, a sort of holistic fingerprint determined by the collective wave function of all its particles. Similar universes, he posits, have similar quantum signatures. The ship's powerful quantum computers are dedicated to a single, monumental task, calculating and mapping these signatures. Starting with the signature of our own home reality, the computers run complex simulations to predict the signatures of adjacent, alternate universes. They calculate the effects of small changes. What would the universal signature be if the gravitational constant were 1/1,000,000% weaker? What if a specific supernova in our past had exploded with slightly more force? This creates a theoretical map of the local neighborhood in the multiverse, a chart of nearby ports of call that the arch could potentially lock onto. This quantum signature map is the navigator's guide. Before initiating a jump, Dr. Blackwell must select a target signature from this map. The arch's systems are then calibrated to resonate with that specific signature. The process is extraordinarily precise. The energy fields must be tuned with an accuracy that makes a laser beam look like a floodlight. A tiny miscalculation in the target signature could result in a failed jump, or worse, a connection to a wildly unstable or dangerous reality. A universe where the laws of chemistry are different, for example, making matter itself unstable. Navigation is an act of supreme mathematical precision. The process is also dynamic. Upon arriving in a new universe, the ship's sensors immediately begin to analyze its actual quantum signature. This new, real-world data is then fed back into the computers, allowing them to refine and expand the map. Each jump provides more information, making the map more accurate, and revealing new, previously unpredicted pathways through the state space. Dr. Blackwell is not just an explorer, he is a cartographer of reality, charting the infinite sea of possible worlds one jump at a time, with his quantum computers drawing the map of a territory vaster than any ocean. Activating an arch is a dramatic event, a symphony of physics and engineering. The ship powers up its vacuum energy siphon, charging massive capacitors. The arch glows, energy surges, and space-time shimmers as a stable wormhole forms. A window to another world opens, held by immense power. Crossing over through an arch isn't just travel, it's a fundamental transition. The ship and its pilot are rewritten, not moved, vanishing from one universe and appearing in another. One moment you're here, the next you're in a new reality, ready to explore a different world. The creation and use of the arches, well, It's an endeavor of almost unimaginable risk. Dr. Blackwell isn't just pushing the boundaries of engineering, he's tampering with the fundamental operating system of reality itself. Just one miscalculation, or a single component failure, could lead to a catastrophe on a scale that's honestly hard to even comprehend. The dangers aren't just to himself and his ship, but potentially to the very fabric of the reality he's leaving behind or entering. He's well aware of these risks, having simulated them countless times, but in practice, the unknown variables are, frankly, terrifying. The most immediate danger lies in the power source. The vacuum energy siphon operates right on the edge of stability. If its containment fields were to fail, the uncontrolled extraction of zero-point energy could, in theory, create a runaway reaction, tearing a hole in space-time and creating a Kugelblitz, which is basically a black hole formed from pure energy. An event like that wouldn't just vaporize the ship, it could destabilize a significant region of the solar system. This is the ultimate sword of Damocles, hanging over the entire project, a constant reminder of the titanic forces being harnessed for this quest. Another big risk is a navigational error. The quantum signature map is, at the end of the day, theoretical. If the calculations are off, the Arch could connect to a universe with radically different physical laws. Imagine emerging into a reality where the strong nuclear force is just a bit weaker. Atoms would fly apart, and the ship would instantly disintegrate into a cloud of subatomic particles. Or maybe, a universe with a much stronger gravitational constant, where the ship would be crushed into a singularity in an instant. The multiverse might contain an infinity of paradises, but it must also contain an infinity of hells, and steering clear of them is literally a matter of life and death. Finally, there's the risk of the unknown and the unforeseen. What if the Arch connects to a universe that's already occupied by intelligent and maybe even hostile life? What about the biological risks of stepping into a world with a completely alien microbiome? And then, there's the feedback problem. Could opening a gateway cause a catastrophic resonance that destabilizes both the origin and destination universes? Dr. Blackwell is a pioneer, stepping into completely uncharted territory, and like all pioneers, he faces dangers he can't even predict. His quest for knowledge comes at the price of confronting the ultimate perils of the unknown. With the ship built, the Arch installed, and the immense risks acknowledged, one final, crucial question remained. Where to go first? The quantum signature map presented Dr. Blackwell with a near-infinite array of potential first destinations. Choosing the initial target was a decision of paramount importance, balancing the desire for profound discovery with the absolute need for safety. He could not simply aim for the most exotic world imaginable. The first jump had to be a conservative one, a proof of concept designed to test the system and validate the theory with the lowest possible risk. After months of careful deliberation and running countless simulations, Dr. Blackwell selected his first target. He designated it Earth Prime -1. This was a reality predicted to be almost indistinguishable from our own. The target quantum signature was one corresponding to a universe where a single, specific, and well-documented radioactive decay event in Earth's distant past had not occurred at the exact microsecond that it did in our timeline. This was a change so minuscule, so far back in history, that its cascading effects on the present day were calculated to be negligible. The target world should be, for all intents and purposes, a perfect twin of our own. The purpose of this choice was twofold. First, it was the safest possible jump. By targeting a universe with virtually identical physical laws and history, the risk of emerging into a hostile or unstable environment was minimized. The ship's systems and Dr. Blackwell's own biology would be perfectly adapted to the destination. He could step out onto this new Earth and breathe the air. Second, it was the perfect scientific control for his experiment. If he could successfully travel to this near-identical world and return, it would prove that the Arch worked and that his method of navigation was accurate. This first journey was not about discovering intelligent dinosaurs or a world where Rome never fell. It was about taking that first tentative step across the threshold of reality. It was about confirming that the bridge could be built and crossed safely. The plan was to make the jump, spend a short time in orbit around Earth Prime -1 to gather sensor data and confirm the match, and then immediately return. If successful, this simple conservative first step would represent the single greatest leap in the history of exploration, opening the door for all the more ambitious journeys that would follow, and marking the true beginning of his mind-bending quantum Odyssey. The moment of passage was both instantaneous and eternal, a blinding flash of non-light, a feeling of being unmade and remade, and then, silence. The deep, resonant hum of the arch faded as the gateway behind the ship collapsed, its duty done. Dr. Blackwell found himself floating in the silent vacuum of space, his ship perfectly intact. The view outside the main viewport was breathtakingly, shockingly familiar. There, suspended in the blackness, was the blue marble of Earth, swirled with clouds of white, glowing under the light of a yellow sun. The first jump was complete. He had crossed the chasm between realities and arrived at his first destination, Earth Prime -1. Immediately, the ship's automated system sprang to life. A cascade of data flooded the screens in the command center. The ship's sensors performed a full spectrum analysis of their new surroundings. The gravitational constant was a perfect match. The speed of light was unchanged. The fundamental forces of nature were identical to his home reality, down to the 15th decimal place. The sun's spectral class, the moon's orbital period, the atmospheric composition of the planet below, everything was exactly as it should be. The navigation had been flawless. The quantum signature map had led him true. It was the ultimate vindication of his life's work. This first arrival was not a moment for grand exploration, but for cautious verification. Dr. Blackwell's mission was to confirm the safety and viability of his technology. He kept the ship in a high, stable orbit, a silent metal moonlet watching over a world that was for all intents and purposes his own. He scanned communication frequencies, picking up the faint chatter of radio, television, and satellite transmissions from the surface. The languages, the news broadcasts, the popular music. It was all the same. The date was the same. The world below was living out a day identical to the one he had just left behind. The success was overwhelming, a quiet moment of triumph millions of miles from any other human being. He had built a bridge to another universe and walked across it. He had proven that the recurrence multiverse was not just a theory, but a navigable landscape. The apple in the box had led him here, to this moment, looking down on a twin of his home world. The first step, the most dangerous and uncertain step of all, had been taken. The door to the infinite library of worlds was now unlocked, and he held the key. The true Odyssey was just beginning. After the exhilaration of the jump, Dr. Blackwell felt the shock of the familiar. He gazed down and saw Paris, London, Tokyo, his own world, perfectly mirrored. Another Michael E. Blackwell was likely down there, unaware he was being watched from orbit. The mission was complete, but the experience changed him. Reality, he realized, was vaster and stranger than he'd ever imagined. Before returning home, Dr. Blackwell had to find the delta, the tiny difference that set this universe apart. Using his quantum sensor array, he scanned the Oklo reactor site in Gabon, searching for a unique quantum signature. Finally, he found it, a single subtle change in isotope, decay, confirming the universe's unique history. With proof in hand, Dr. Blackwell reactivated the arch. It was time to go home. After returning to his home reality and spending months analyzing the data from the first jump, Dr. Blackwell was ready for the next phase of his exploration. The test had been a success, but the true potential of the arches lay in visiting worlds that were not identical twins, but estranged cousins. He wanted to witness a world where human history had taken a different path. He spent weeks searching the quantum signature map for a suitable target. He was looking for a reality that was still physically stable and safe, but one where a key historical event had played out differently, leading to a measurably different present day. He found the perfect candidate, a universal state he designated Earth Hesperus 7. The divergence point was in the late Roman Empire. In our timeline, the Library of Alexandria, a beacon of ancient knowledge, suffered a slow decline and was ultimately destroyed, its vast collection of scrolls lost to history. The simulation predicted a reality where a significant portion of the library's knowledge, particularly its scientific and engineering texts, had been saved and disseminated. The predicted outcome was a world that had experienced an industrial revolution over 1,000 years earlier than our own, spearheaded by a technologically advanced Roman civilization. The prospect was tantalizing. The risks for this second jump were considerably higher. While the fundamental laws of physics were expected to be the same, the world itself would be vastly different. The geopolitical landscape, the technological level, even the very climate of the planet could have been altered by such a profound change in history. He updated his ship's threat assessment software and prepared for a wider range of contingencies. This was no longer just a test of the machine, it was a true exploration into the unknown. A journey into an alternate present shaped by an alternate past. With the coordinates locked in, he initiated the activation sequence. The hum of the ship's core filled the air once more, the arch glowing with power. The sense of anticipation was electric. He was about to open a window not just to another place but to another time, another history. What would a world built on Roman ingenuity look like? Would it be a utopian society powered by steam and logic, or a global empire held by iron and force? He was about to find out. The gateway shimmered into existence, and with a steady hand, Dr. Blackwell piloted his ship across the threshold into a different stream of time. Emerging into the orbit of Earth Hesperus 7 was a breathtaking experience. The planet below was recognizable as Earth, but it was a changed world. The night side of the planet glowed with far more extensive and organized networks of light than his own, tracing patterns of unseen continents. The atmosphere held a noticeably higher concentration of industrial byproducts, a sign of prolonged, widespread manufacturing. Even from orbit, it was clear this was a world that had been thoroughly and globally industrialized for centuries. The quantum signature map had been right. He was looking at the legacy of a Roman industrial revolution. He brought the ship into a geosynchronous orbit over the Mediterranean, the heart of the old Roman Empire. Using the ship's telescopes, he peered down at a world that was a fusion of the ancient and the hyper-modern. He saw cities with the familiar layout of Roman camps, but filled with towering structures of brass and iron, spewing steam into the sky. Aqueducts, massive and intricate, ran for thousands of miles, but they carried not just water, but also power cables and communication lines. Great gear-driven bridges spanned rivers, and fleets of iron-hulled, steam-powered ships crisscrossed the sea. It was a world imagined by Jules Verne, brought to life. The society seemed to be a global technocracy, an extension of Roman logic and engineering. Latin, or a modernized version of it, appeared to be the planet's lingua franca, used in the technical readouts and public broadcasts he intercepted. The world was not divided into the same nations he knew. Instead, it was organized into large, continent-spanning administrative provinces, all seemingly under the authority of a central power based in Rome. It was a world of order, efficiency, and immense technological achievement, built on a foundation of knowledge that in his world had been lost to fire and time. Dr. Blackwell spent weeks in orbit, a silent observer of this alternate history. He recorded their technologies, their social structures, their art. He saw wonders, like vast automated farming complexes in the Sahara, made fertile by continental-scale irrigation projects. But he also saw signs of the costs of this progress. The planet's environment was clearly under strain, and the rigid, centrally controlled society seemed to lack the chaotic, vibrant diversity of his own world. It was a powerful lesson in how a single pivot point in history could send humanity down a completely different path, creating a world of marvels and cautionary tales. The journey to the Roman industrial Earth was just the beginning. Emboldened by his success, Dr. Blackwell began a series of carefully planned jumps, each one targeting a world with a different, more profound divergence. He was, in a way, a cosmic naturalist, cataloging the strange and varied species of reality that had evolved from different starting conditions. He visited an Earth where the Cretaceous-Paleogene extinction event never happened, a lush, hothouse world dominated by immense flora and fauna, where, interestingly, intelligent life had not yet evolved from mammals. He orbited in silence, just watching colossal, long-necked creatures browse the tops of skyscraper-sized trees, a vision of Earth's deep past, living in the present. He then jumped to a world where the axial tilt of the planet was far more extreme, creating seasons of unimaginable severity. The dominant civilizations on this world had not built on the surface, but had burrowed deep underground, creating vast subterranean cities powered by geothermal energy. He saw a world where humanity had been forced to turn inward, their culture and technology shaped entirely by the need to survive the planet's brutal climate cycles. It was, honestly, a testament to the resilience of life and intelligence, a world of darkness and warmth, of geology and community, utterly alien to his sun-drenched home. Not all the worlds he found were hospitable. One jump took him to a reality where a nearby star had gone supernova much later in Earth's history, scouring the planet of its atmosphere and boiling away its oceans. He arrived to find a dead, sterilized rock, a silent, orbiting tombstone. It was a stark and terrifying reminder of the cosmic fragility of life, a world of warning that underscored just how fortunate his own Earth had been. He logged the data with a heavy heart and quickly left, the image of the dead world seared into his memory as a memento mori for an entire planet. Through these journeys, Dr. Blackwell began to appreciate the full spectrum of possibility. He saw worlds of breathtaking wonder and worlds of profound tragedy. He saw a water world where humans lived in magnificent floating cities, and a desert world where life clung to existence around a few scattered oases. Each reality was a unique solution to the problem of existence, a complete and internally consistent universe with its own history, its own triumphs, and its own failures. He was no longer just exploring other Earths, he was exploring the very nature of possibility itself, witnessing the infinite creativity of the cosmos firsthand. Dr. Blackwell traveled worlds, burdened by the ethics of observation. He refused to interfere, knowing even a cure or a gift could cause disaster. He was a witness, not a savior, leaving no trace, taking nothing, not even memories. His greatest challenge was ethical, to respect each reality, learning wisdom and restraint on his journey. Dr. Blackwell's journey, sparked by a simple apple in a box, leads to a profound lesson. The multiverse is a mirror, reflecting endless versions of ourselves. Our reality is just one among infinite possibilities, each world showing what we might have become. The multiverse doesn't diminish us. It reveals the beauty and creativity of existence itself. Dr. Blackwell journeys alone, the first human to witness infinite worlds, steam-powered Roman airships, floating cities, alien skies. He carries the silent burden of knowledge he cannot share, a ghost in the multiverse, watching triumphs and tragedies unfold. Yet in solitude, he finds awe and clarity, his lonely vigil forging the future of human understanding, one wondrous discovery at a time. Dr. Blackwell's journey was never just for one man. It was a proof of concept for all humanity. He dreams of opening the multiverse, responsibly, for everyone, believing it holds answers to our deepest questions. Blackwell envisions a united humanity, inspired by the cosmos, working together for a wiser, shared future. His Odyssey is just the beginning. Have you ever looked up at the night sky and felt a sense of déjà vu? We see cycles all around us. The sun rises and sets, the seasons turn, and our lives follow a rhythm. But what if this repetition goes deeper? Is our universe unique, or could there be another you living a similar life elsewhere? Today, science and quantum physics let us explore these ancient questions with new tools. The journey begins now. The concept of a new Big Bang is examined through various cosmological models, including the cyclic model and loop quantum cosmology. The cyclic model proposes that the universe may undergo a series of cycles involving expansion and contraction, with each cycle potentially resulting in a new Big Bang. Throughout history, pioneers like Copernicus and Einstein have dared to see the universe differently. Today, Dr. Michael E. Blackwell joins their ranks, a physicist driven by wonder, connecting quantum particles to galaxies. He believes the universe cycles through every possible state, and dreams of building a bridge to other worlds. Dr. Blackwell is a modern-day pioneer, exploring the very fabric of existence. Imagine an apple, simple, familiar, made of countless molecules and atoms. Place it in a perfectly sealed box, isolated from the universe. The apple decays, breaks down, and its atoms move endlessly. Over unimaginable time, those atoms will explore every possible arrangement. And eventually, they'll form a perfect apple again, a return to the beginning. The apple in the box is more than a puzzle, it's a model for the universe. Imagine the universe as the ultimate isolated box. It began with the Big Bang, expanding and cooling. Over time, stars will burn out, galaxies will collide. Eventually, a new Big Bang could occur, repeating the cycle. Dr. Blackwell's theory isn't just philosophy, it's a call to action. If parallel Earths exist, could we visit them? His invention, the arches, could be humanity's gateway to these worlds, using quantum entanglement for instant travel. Dr. Blackwell dreams of stepping through the arch, exploring alternate Earths, and unlocking the mysteries of existence. Look closely at an apple, not just as fruit, but as a miniature universe. Its vibrant skin hides a world of complexity: water, sugars, fibers, and countless molecules, all organized in a delicate balance. Each atom has a cosmic history, forged in stars and gathered on Earth. This apple is a fleeting collection of ancient stardust, a microcosm of the universe, and a perfect example of order in a chaotic world. Introducing Dr. Blackwell's thought experiment. The box. This is no ordinary container. Imagine a perfect cube, completely sealed off from the universe. Inside, it's a closed system. In reality, an apple interacts with its environment. But inside our box, it's left to its own devices. The box creates a controlled environment where time is the only change agent. We've captured a moment, sealing it away. Once sealed in its glass box, the apple begins its inevitable decay, a journey of increasing entropy. The crisp, ordered fruit breaks down, its structure dissolving into a pulpy, disordered mess. This is the apple's first death, driven by the unyielding laws of thermodynamics. But for Dr. Blackwell, this is only the beginning. The universe is not done with these atoms yet. The apple has decayed, but at the atomic level, nothing is ever truly still. Atoms and molecules are in constant, random motion, colliding, vibrating, and shifting in endless patterns. This quantum jitter ensures the system never truly gets stuck. Even in a lifeless mix, the universe is always shuffling the deck, with atoms exploring new combinations every moment. Imagine the atoms in a box as a giant lottery, each arrangement a unique ticket. There are impossible states, astronomically vast but not infinite. The fresh apple is one ticket, the rotten sludge another. Over unimaginable time, the system will eventually draw every ticket, exploring every possibility encoded in the apple itself. In the cosmic lottery, atoms endlessly shuffle, exploring every possible arrangement. Apples, diamonds, even baseballs. Given enough time, the improbable becomes inevitable. The box could hold a baseball, a flower, or a clock. Objects are just fleeting patterns. Atoms are the only permanent reality in this grand game of existence. After cycling through endless forms, diamond, baseball, gas, water, the system exhausts all possibilities. By pure chance, the atoms return to their original state. The apple is reborn. This is the Poincaré recurrence, a perfect cycle, where the apple returns, and the journey begins again, forever. The apple in the box is more than a thought experiment, it's a metaphor for our universe. Like the apple, the universe is a closed system, cycling through endless states. Our planet, our sun, even ourselves, temporary patterns in a cosmic cycle. The apple's journey is a blueprint for reality. Everything that has happened will happen again. Dr. Blackwell's apple-in-a-box experiment helps us imagine the universe as the ultimate closed system. Replace the apple with every star and galaxy, and the box with the universe itself. The universe, vast but finite, is a self-contained arena with its own rules and ingredients. Like the apple, our cosmos may be destined to repeat its story, cycling endlessly within its cosmic box. If the universe is finite, then its components can only be arranged in a limited number of ways. Imagine every particle as a card in a cosmic deck. Each arrangement is a unique hand. Quantum physics tells us there's a hard limit to these possible states. Shuffle the deck enough, and eventually, the universe repeats its hands. The universe began in a state of incredible order, a profound mystery in physics. From the Big Bang, it has been expanding, cooling, and becoming more disordered. Following the second law of thermodynamics, this increase in entropy gives time its direction, the arrow pointing from order to chaos. Stars, as pockets of order, burn their fuel, spreading energy and increasing entropy. Over time, stars die, and galaxies disperse, akin to an apple rotting. Cosmologists predict a state known as heat death, a cold, dark end. After eons, all stars will burn out, matter will decay, and black holes will evaporate. The universe will be a vast, cold expanse, filled with stray particles reaching maximum entropy. In this state, meaningful activity ceases, and the universe becomes a quiet, unchanging place. Yet, for Dr. Blackwell, this is merely an intermission. not the final chapter. The quantum jitter, the random motion of particles continues, waiting to be shuffled again. The cosmic deck of cards remains, ready for a new beginning. Even in heat death, the universe isn't truly at rest. At the smallest level, space-time is a chaotic sea of energy, known as quantum foam. Virtual particles pop in and out of existence, borrowing energy from the vacuum. This quantum jitter is the engine of cosmic rebirth. Over unimaginable timescales, a rare quantum fluctuation could occur. A large amount of energy might concentrate, resembling the initial Big Bang. This spontaneous decrease in entropy is statistically miraculous but possible. Such an event would ignite a new universe within the old one's remains. Given infinite time, this universe-creating fluctuation is inevitable. The universe contains within its fabric the mechanism for its own resurrection. The Poincaré recurrence theorem suggests a system will eventually return to its starting point. Applied to the universe, it becomes a prophecy of cosmic repetition. Our universe, a finite closed system, must eventually cycle through states and return to a similar configuration. A new Big Bang will occur, and the universe will evolve, repeating its history. This isn't just a new universe but the same one, replaying its scenes. The universe's finite states mean it must start over after exhausting possibilities. This recurrence is an endless cycle, not a single event. The universe's history is a circle, not a straight line. We live in one turn of a cosmic wheel that has turned infinitely before, and will turn infinitely again. The Poincaré recurrence transforms reality into a chapter in an eternal, repeating story. How long until the universe repeats? The Poincaré recurrence time is a colossal number. For a complex system like the universe, this time is unimaginably vast. It's a number so large it defies comprehension, dwarfing the universe's current age. These events, heat death, quantum fluctuation, rebirth, are logical extrapolations over infinite time. The theory doesn't predict immediate repetition but eventual recurrence. The cosmic recurrence time highlights the universe's vast state space. It shows that while the unlikely is possible, the miraculous requires immense time. The universe has infinite time to explore every possibility before starting over. This patience is a testament to the universe's vastness. The universe will use its time to explore every possibility. The cosmic recurrence time suggests the universe will repeat, but there's a more immediate implication. In a finite universe, repetition is a matter of space, not just time. If the universe is vast enough, any configuration is bound to repeat somewhere. Like shuffling a deck of cards, repetition is statistically inevitable. In a vast universe, there are countless volumes of space with different particle arrangements. It's inevitable that somewhere, there's a volume identical to our solar system. This means another Earth, with another sun, exists somewhere. The laws of probability demand this repetition. Other Earths exist now, not just in the distant future. The universe has already dealt every possible hand somewhere. If another Earth exists, it would have the same history and people. This leads to a profound implication. A cosmic twin of you exists. This twin would have the same genetic code, memories, and consciousness. They would live the same life, making the same choices. This challenges our sense of individuality and uniqueness. Our identity is a pattern that repeats across the universe. This repetition amplifies our existence, showing its fundamental nature. In an infinite universe, there are infinite cosmic twins and near twins. The universe is a tapestry of every possible story, with your life as a recurring theme. Your life, in all its variations, is an intricate thread in the cosmic tapestry. His theories are not just intellectual exercises meant to be confined to academic journals and lecture halls. They are a map, and every great map inspires a journey. The conclusion that other Earths exist is a starting point. This question marks the transition from theorist to inventor, building a bridge to cross voids separating parallel realities. The dream solidified around the arches, a gateway, a project of monumental scale, testing the nature of existence. At the very core of the arch's invention lies one of the most bizarre and, honestly, proven phenomena in all of science: quantum entanglement. Albert Einstein famously described it as, spooky action at a distance. It's a process where two or more quantum particles become linked in such a way that their fates are intertwined, no matter how far apart they are separated. If you measure a property of one particle, you instantly know the corresponding property of the other. This connection is instantaneous, seemingly violating the universal speed limit set by the speed of light. This spooky, faster-than-light link is the secret ingredient that he, Dr. Blackwell, plans to use as his method of transportation between worlds. The challenge, however, is one of scale. Quantum entanglement has been demonstrated countless times in laboratories, with tiny particles like photons or electrons. But honestly, no one had ever conceived of entangling macroscopic objects, things you can actually see and touch. His revolutionary breakthrough was the theory of macroscopic coherent entanglement. He proposes that under extreme conditions of energy and using specialized resonance fields, it would be possible to entangle two complex systems, such as his ship and its home base. The arches are the machines designed to create and sustain these extreme conditions, weaving a stable quantum connection between two large-scale objects across the fabric of space-time. To achieve this, the ship and a stationary anchor point on Earth must be brought into a state of perfect quantum coherence. This means every particle in both systems must be cooled to near absolute zero and shielded from all external vibrations and radiation. In this state of profound stillness, the arches can emit a precisely tuned resonance wave. This wave doesn't push the objects, it coaxes their collective quantum states into a single, unified, entangled system. The ship and its anchor become, in a quantum sense, two parts of the same object. A change in the state of one is now instantly mirrored in the state of the other, just like the two tiny entangled photons in a lab experiment. This process is incredibly delicate and energy-intensive. The slightest disturbance could break the fragile entanglement, a phenomenon known as decoherence. The arches must function as the most sophisticated stabilization chambers ever built, maintaining the entangled link against the constant noise of the universe. This link is the highway he intends to travel. It's not a physical road, but a connection of pure information, a quantum thread woven through the cosmos. By manipulating this thread, he believes he can exchange the ship's location in our reality with a corresponding location in another, without ever crossing the distance in between. The heart of his machine is this spooky, invisible, and instantaneous bond. The arches themselves are honestly masterpieces of futuristic engineering, designed to facilitate the miracle of macroscopic entanglement. They are not just one, but two identical structures. One arch is built at the home base on Earth, a massive stationary installation housed in a deep underground facility to shield it from cosmic rays and seismic activity. The second, smaller arch is built directly into the structure of his ship, the vessel he calls the Prometheus. These two rings are the physical terminals for the quantum connection. They are designed to generate the immense, focused energy fields required to first create and then manipulate the entangled state between the ship and its terrestrial anchor. Each arch is a perfect circle, hundreds of meters in diameter for the ground-based unit. It's constructed from a custom-engineered metamaterial, a substance designed to manipulate electromagnetic fields in ways no natural material can. The surface of the arch is embedded with millions of superconducting quantum emitters. When activated, they work in perfect unison to create the coherent resonance field that initiates the entanglement. The energy required to power such a device is colossal, equivalent to the output of several nuclear power plants, all channeled into a single sustained pulse. The architecture is a fusion of brute force power generation and the most delicate quantum control imaginable. When the system is engaged, the space within the circle of each arch begins to shimmer, the air itself seeming to warp and glow with a soft, ethereal blue light. This is the visible effect of the intense energy field interacting with the local space-time fabric. This field doesn't just prepare the ship and base for entanglement, it also acts as the dial for the system. By subtly modulating the frequency and geometry of the energy field, Within the ship's arch, he can target a specific destination reality. The arch essentially tunes the quantum connection to a universe with a specific vibrational signature, one that matches the profile of a world like Earth. The design process was, honestly, an iterative loop of theory and simulation. He and his team ran countless supercomputer models, simulating the behavior of the quantum fields and refining the arch's design to ensure stability. They had to invent new cooling systems to handle the immense waste heat and new control algorithms to keep the millions of emitters in perfect sync. The final design is a structure of haunting beauty and, honestly, terrifying power. It is a gateway, a focusing lens for reality itself. It is the physical apparatus that will allow me to reach through the veil of our universe and touch another, proving that what was once magic is now simply a matter of engineering. The vessel that will carry me through the arches is, honestly, as remarkable as the gateways themselves. Named the Prometheus, it is far more than a simple transport. It must function as a self-sufficient laboratory, a long-term habitat, and a robust exploration vehicle, all while incorporating the miniaturized arch required for its half of the entanglement process. The ship is not designed for atmospheric flight or landing on planetary surfaces in the conventional sense. Its purpose is to exist in the void of space, a sanctuary and a scientific outpost that can be positioned in the orbit of other worlds. It is, in essence, a home that can be moved between universes. The Prometheus's design is sleek and functional, a flattened spheroid shape that maximizes internal volume while providing optimal structural integrity and shielding. Its outer hull is a multi-layered composite, designed to protect its delicate internal systems and crew from the harsh radiation of deep space in any reality it might visit. The ship is powered by a next-generation compact fusion reactor, providing the immense energy needed for the onboard arch, life support, and scientific instruments. It is a completely closed-loop ecosystem capable of recycling all air, water, and waste, allowing it to operate independently for decades without any external supplies. This autonomy is crucial for a mission into the ultimate and the unknown. Inside, the Prometheus is divided into several key sections. The heart of the ship is the control deck and the integrated arch chamber, where he will oversee the quantum transits. Surrounding this are state-of-the-art labs, equipped to analyze everything from atmospheric composition to, well, alien biology, should we encounter it. There are also comfortable living quarters, a hydroponics bay for growing fresh food, and a comprehensive digital library containing the entirety of human knowledge. The ship is designed to be a bubble of our world, a familiar base of operations from which to explore the unfamiliar. It is a testament to meticulous planning for a journey where nothing can be taken for granted. Ultimately, the Prometheus is a vessel of hope and curiosity. It is the embodiment of the human desire to explore, packaged into a single, self-contained machine. It is both a ship and a destination. When it passes through the arch, it will not just be carrying a crew, it will be carrying the accumulated knowledge and aspirations of our world. He designed it not just to survive the journey, but to be a worthy ambassador to the other Earths he hopes to find. It is a home between worlds, a sanctuary of science and reason, ready to embark on the greatest voyage of discovery ever undertaken by humanity. The journey that the Prometheus will take is fundamentally different from any travel we have ever known. It does not involve accelerating to incredible speeds, or physically crossing the distance between stars or galaxies. Instead, it utilizes the entangled link between the ship's arch and the arch on Earth to perform what I call a state-space transition. This is, the practical application of the so-called spooky action at a distance. It is not faster than light travel in the conventional sense. Honestly, it's better described as instantaneous relocation. The ship does not move through space, it redefines its position within it. It's less like a journey, and more like changing the channel on a cosmic television. The process begins once the macroscopic entanglement between the Prometheus and its home base is stable. The ship is, in a quantum sense, in two places at once: its physical location in our space, and its entangled potential location defined by the arch system. By feeding a specific set of coordinates into the ship's arch, coordinates that describe the quantum signature of a target reality, he initiates the transition. The arch's energy field modulates the entangled connection, effectively offering a new state to the system. This new state is one where the ship exists in the same relative spatial location, but within the fabric of a different universe. When the system accepts this new state, the transition occurs. For just a fraction of a second, the Prometheus dematerializes from our universe. It does not explode or fly apart. Its physical information is translated through the quantum tunnel of entanglement. It ceases to exist here and begins to exist there. From the perspective of an observer on the ship, the experience would be disorienting but instantaneous. The stars outside the viewport would blink out of existence and be replaced by a new set of stars, orbiting a new Earth. The ship would have jumped from one parallel track of reality to another without ever experiencing the journey between. This form of travel is the only way to make his dream a reality. It bypasses the tyranny of the speed of light, which makes interstellar and interuniversal travel impossible. It is frankly a profound cheat, a loophole in the laws of physics that only becomes apparent at the quantum level. The energy cost of one such jump is immense, but it is a finite cost for an infinite journey. The quantum tunnel doesn't move the ship through space, but moves space around the ship. It is the ultimate expression of human ingenuity, turning the universe's most esoteric rule into a practical method of transportation. The final piece of the puzzle is perhaps the most challenging: how to find a destination. The arches can theoretically open a gateway to another world, but which world? In a multiverse of infinite possibilities, how do you aim for a specific target? You cannot simply point a telescope and look for another Earth, as it exists in a separate reality, invisible to us. His solution is as ingenious as the arches themselves. He plans to use the universe's own repetition as a beacon. He's not looking for another Earth. He's listening for its echo in the fabric of space-time. It's a search based on resonance and probability. He theorizes that every universe has a unique fundamental vibration, a sort of cosmic background signature determined by its overall state of matter and energy. Universes that are in very similar states, like two near-identical Earths, should have nearly identical signatures. His team has spent years building a vast array of hypersensitive quantum sensors, designed to listen for the faintest fluctuations in our own space-time, minuscule echoes that might bleed through from adjacent realities. We're searching for a signature that is an almost perfect match for our own, a sign of a cosmic twin vibrating in tune with us across the multiverse. This is, honestly, the search for a needle in a haystack of infinities. After years of patient listening, they believe they have found one. A faint, persistent signal that matches the quantum signature of our home reality to an unprecedented degree of accuracy. It is a statistical ghost, a whisper so faint it is almost indistinguishable from background noise. But it is there. This signal is our foremost target. It is the address of what they hope is a sister Earth, a world so similar to ours that it is effectively a copy. The coordinates for this target reality have been programmed into the Prometheus's navigation system. The arch will be tuned to the specific frequency of this cosmic echo, aiming the quantum tunnel at this one specific destination out of a near infinite number of choices. This first journey is the ultimate test. It's a leap of faith grounded in the most advanced physics ever conceived. If he's right, the Prometheus will dematerialize from our orbit and rematerialize in the orbit of another Earth, a world bathed in the light of a familiar yellow sun. He will be the first human to witness a cosmic repetition, to see with his own eyes the proof of his life's work. The success of this first jump will not only validate his theories, but will also open up a new era of exploration, transforming humanity from a single-world species into true citizens of the multiverse. The destination is set, and the Prometheus is ready. The transition is instantaneous and utterly silent. One moment, the Prometheus floats above Earth. The next, they face a world both familiar and alien. Every cloud, every ocean, every continent below mirrors home. Yet the constellations are wrong. The quantum tunnel worked. He and the crew stare in awe. This is not just a planet like Earth. It is a functional duplicate. The air teems with radio signals, the hum of another humanity, unaware of our watchful eyes. The arches have opened a door to a new understanding. The journey has only just begun. With focused determination, I initiate the protocol of observation. There will be no landing, no announcement. Their prime directive, absolute non-interference. The Prometheus remains a silent observer, watching a world eerily identical to our own. They study their cities, their lives, searching for any difference. For now, the reflection is perfect, more unsettling than any difference they could have imagined. Days turn into weeks as the Prometheus continues its silent vigil. The initial awe has been replaced by a methodical, almost obsessive search for divergence. He and the team delve into the historical data they've downloaded, cross-referencing it with our own world's history. They start with the major turning points of the 20th century. The World Wars, the Cold War, the moon landing, event by event, date by date, the histories align with terrifying precision. The same leaders made the same speeches. The same battles were won and lost. The same treaties were signed. This world's Neil Armstrong also took one small step onto the lunar surface in 1969, uttering the very same immortal words. The search becomes more granular. They begin to analyze smaller, more obscure historical events, looking for the butterfly effect in action. Did a key scientific discovery happen a year earlier here? Did a minor political figure win an election they lost back home? They comb through birth and death records of historical figures, financial market data, and sporting event outcomes. The 1986 World Series, a famous painting sold at auction in 2017, the path of a major hurricane in 2005, it all matches, the mirror holds. The universe, it seems, does not just repeat its broad strokes, it repeats its finest details with painstaking accuracy. This level of fidelity is honestly beyond what even he had predicted. This perfect repetition raises a profound philosophical question. How much of human history is driven by chance, and how much is predetermined by the initial conditions? The evidence from this other Earth suggests that contingency plays a much smaller role than believed. It implies that given the same starting point, the same planet, the same biology, the same physical laws, the story of humanity might be almost inevitable. The rise of agriculture, the development of empires, the scientific revolution, the digital age, perhaps these are not remarkable accidents, but stable, probable outcomes for a species like ours. It's a humbling and deterministic view of our own existence. The crew begins to feel a sense of cosmic claustrophobia. If this world is a perfect copy, then what is the point of the exploration? Are they just confirming that the universe is a boring, repetitive machine? But he remains convinced that a difference must exist. A quantum system as complex as a planet populated by billions of conscious beings cannot be perfectly stable. The inherent randomness at the subatomic level must eventually bubble up to the macroscopic world and cause a deviation, no matter how small. The search is not over. It just needs a closer look to find the single thread that is out of place in this perfectly woven tapestry. After weeks of observation, they finally spot it, a tiny anomaly in a stock price, just a 1-cent difference. It's the first crack in the mirror, proof these worlds aren't identical. A mayoral election winner is different, subtle changes, but profound. This world is almost ours, but not quite. Each small difference reveals a unique sibling reality. The discovery of microdivergences leads him, Dr. Blackwell, to the most dangerous phase, observing a cosmic twin. They find a professor in Florence, her life mirrored on two Earths. For weeks their lives are perfectly synchronized, until a single random choice splits their paths. This moment proves it. Even in a repeating universe, individual choice matters. And he knows he must never meet his own twin. The risk is too great. The mission is a success. They've seen our universe is just one of many, and our uniqueness is a fragile, precious thing. This knowledge is a burden, too powerful to share. He and his crew must keep this secret, guardians of humanity's hope. The arches are not just for exploration. They are a lifeboat, a promise of a second chance. They return home, forever changed. They began with a simple question, imagining an apple sealed in a box, decaying with time. This became their lens for the universe, a vast, isolated system cycling through creation and decay. They learned the universe repeats, not just in time, but in space. Every possible world, including other Earths, is inevitable. In the end, the echo they sought in the void was our own. The Prometheus returns, its databanks filled with knowledge that could shatter humanity's sense of meaning. Dr. Blackwell and his crew choose to keep this secret, becoming silent guardians of a truth too powerful to share. Their mission changes. They become secret cartographers of the multiverse. carrying a burden that is also a sacred trust, protecting humanity and holding the key to our survival should catastrophe ever strike. Perhaps the most personal and hopeful discovery from the Prometheus's journey was not the grand repetition of history, but the tiny, beautiful imperfections in the mirror. The 1 cent difference in a stock price, the song that charted one position lower, and most poignantly, the professor's impulsive decision to enter a bookshop while her twin walked on by. These moments of divergence are where the true poetry of the cosmos resides. They teach us that even in a universe of near-infinite repetition, there's still room for novelty. The destiny of the cosmos may be written in broad strokes, but the fine details are painted by the brush of chance. This discovery is a powerful counter-argument to the potential despair of a repeating universe. If everything were perfectly identical, one might conclude that our choices are meaningless, that we are all just actors reading from the same script. But the subtle differences prove otherwise. The quantum randomness that underpins reality, the unpredictable firing of a single neuron, can cascade into a unique choice, a different path taken. This means that your life, right now, is a unique performance. While countless others may be living similar lives, the specific sequence of choices you make, the thoughts you think, and the feelings you experience belong to you and you alone in this moment. This imbues every single choice with a profound significance. The decision to be kind, to create art, to pursue knowledge, or to love another person is not just a predetermined action in a cosmic play. It is your contribution to the unique tapestry of this specific reality. Dr. Blackwell's journey didn't erase free will, it enshrined it in the heart of quantum mechanics. It suggests that our consciousness, interacting with the fundamental randomness of the universe, has the power to forge a unique path. However, subtly, it may differ from its parallel counterparts. You are not just an echo, you are a distinct voice in the cosmic choir. Therefore, the lesson from the other Earth is not one of fatalism, but one of empowerment. It calls us to recognize the preciousness of our own agency. The professor who entered the bookshop created a new reality for herself, a new set of experiences that her twin will never know. In the same way, every decision we make sends ripples through our own lives, creating a story that has never been told in exactly this way before. The repeating universe does not make our lives less meaningful, it highlights the incredible unique value of a single, individual choice in a sea of near-infinite possibility. It tells us that what we do here, now, truly matters. Dr. Blackwell's Quantum Prometheus forces us to expand our definition of we. For all of human history, we has meant our family, our tribe, our nation, or at its most expansive, our species on this single planet. We have defined ourselves by our shared home and our shared history. The discovery of other Earths shatters this parochial view. The family of humanity is suddenly, unimaginably larger. We now includes the countless other humans on countless other Earths, living lives that are both identical and subtly different from our own. They are our cosmic relatives, our lost siblings, separated not by oceans, but by the very fabric of reality. This realization fosters a new kind of cosmic empathy. When we look up at our own sky, we can now know that another version of us is looking up at a similar sky, asking the same questions. The struggles, joys, and sorrows of humanity are not unique to our world. The same dramas of love, loss, conflict, and discovery are playing out on a near-infinite number of stages. This shared experience across realities creates a bond that transcends physical distance. It suggests that the human condition is a fundamental constant of the cosmos, a recurring pattern as inevitable as the formation of stars. We are not a cosmic accident, but a cosmic habit. This new perspective could, if ever revealed, become the ultimate unifying force. The petty divisions that separate us on our own world, race, nationality, religion, seem insignificant when faced with the knowledge of our countless twins across the multiverse. The greatest us versus them becomes our Earth versus their Earth. But even that dissolves when we realize their Earth is our Earth. The ultimate conclusion is that there is no them, there is only a vast, extended us. This perspective encourages us to see humanity as a single sprawling entity, a single consciousness exploring itself through a multitude of variations. Dr. Blackwell's journeys, therefore, are not just about exploring other worlds, they are about discovering the true scope of our own. The Prometheus travels to other Earths to hold up a mirror to ourselves, to understand what it truly means to be human. The answer it brings back is that being human is a universal phenomenon. We are part of a cosmic family so vast, it defies imagination. This knowledge redefines our place in the universe, transforming us from lonely inhabitants of a single, isolated world into members of a grand, multiversal community. Our home is not just Earth, it is every Earth. The first journey of the Prometheus was a proof of concept. It was a tentative step into a new ocean of reality, a voyage to the nearest, most familiar shore. But the existence of one other Earth implies the existence of countless more, and not all of them will be near-perfect copies. The successful mission opens the door to the next great era of exploration, a journey not just to our twin, but to our cousins. The arches can be tuned, their destination targeted. The next great journey will be to intentionally seek out worlds where history has diverged in more significant ways. This is where the true scientific and philosophical treasure lies. Imagine a voyage to an Earth where the Roman Empire never fell, its technological and cultural influence shaping the globe for 2 millennia. Or a world where the dinosaurs were not wiped out by an asteroid, and intelligent life evolved from saurian ancestors, creating a civilization of beings we can scarcely imagine. What could we learn from their history, their biology, their art? Each of these worlds would be a living laboratory, a control group in the grand experiment of life and civilization. By studying their successes and their failures, we could gain invaluable insights into our own path, learning from mistakes that other humanities have made. The potential for discovery is limitless. Dr. Blackwell and his team could visit an Earth that has solved climate change, or one that has succumbed to it, providing a stark vision of our possible futures. They could find a world that has achieved global peace and study the social and political structures that made it possible. They could even search for worlds where the fundamental constants of physics are slightly different, leading to a reality with entirely new scientific laws to uncover. The Arches have given humanity a tool not just for travel, but for comparative cosmology, for anthropology on a scale that was previously the sole domain of fiction. This is the promise that fuels the continuation of the secret mission. The goal is no longer just confirmation, but a grand intellectual synthesis. The Prometheus will become a vessel of cosmic wisdom, gathering knowledge from the library of all possible worlds. This next great journey is a quest to understand the full spectrum of what is possible, to see all the paths that life and intelligence can take. It is a journey beyond the familiar horizon of our own history, into the boundless territory of what if. It is the search for humanity's place not just in our universe, but in the landscape of all possible universes. From a single apple to infinite Earths, our journey is fueled by curiosity. The universe is more magical and mysterious than we imagined. Science invites us to question, to wonder, and to explore. Let this be your invitation, to look up, to ask, and to discover.